All right, I would say that this top part is a little more challenging than the ones that will be on your quiz, but it still has the same concepts in it, so it's worth talking about. The first thing I like to do is try to figure out all of the arcs around the outside of the circle. And so I like to look for diameters, and I can see a diameter right here. So that means that this half of the circle is 180 degrees. So I would start by finding the measure of arc AE. So 180 minus 66 is 114. Another thing I notice is these chords are congruent. And if those chords are congruent, then these arcs are congruent. That's an old theorem that we learned, I think, in the first lesson. And then I think I would look at another half circle, this semicircle over here. All of those arcs have to add up to 180. So 180 minus 100 minus 66 leaves us with 14 degrees for right here. Once you have all of that filled in, then you should be able to do all of the things in the arcs column. So we know that AE was 114, DE, we figured that out, BC, we figured that out. AC would just be 66 plus 14, so 80. BED, that's a major arc going from B through E and then to D. So we could take 66 plus 114 plus 66, which is 246. A through D through E, the major arc. A to D to E. That's the entire circle except for the 144. Or we could just add up all of those arcs going around. Shortcut 360 minus the part that we're not including. That one's actually 246 as well. Let's move to the theorem that says if you were finding angles, did you notice all the angles here have their vertex on the circle? For vertex on the circle, or the angle is the arc divided by 2. So we're going to be doing a lot of dividing by 2. Angle BEA. BEA is this angle, which is chomping down on the 66. So that arc divided by 2, 33. From C to E to B is chomping down on that 14. So that would be 7 degrees, 14 divided by 2. B to D to E is chomping down on the entire half circle over here. You see this triangle that's hypotenuse as the diameter? That is a right triangle. So we could take the 180 divided by 2, or we could see that right triangle in there. From A to C to E, that is intercepting the 114 degree arc. 114 divided by 2. E to B to D. E, B, D. The angle over at B opening up to the 66. And E to A to C is opening up to this entire arc. 166 divided by 2 would be 83 degrees. I love these bottom questions because it kind of gives you an overview of everything we learned. So these first two are about a secant line and a secant line. The next two are about a chord and a chord. And the last two are about a secant with a tangent. And so it kind of has every possibility of anything I could ask you about this kind of stuff. Let's start with the angles. Remember, the angles are always like arc divided by 2, or arc plus arc divided by 2, or arc minus arc divided by 2. So that's what we're looking for on these. Since this angle has its vertex outside the circle, that angle is going to be equal to the arc minus the arc divided by 2. So 90 minus, and the way that I knew it was those two arcs is because if I picture that as the mouth chomping down, it's chomping this one and that one. Anyway, we're gonna have to figure out what that arc is, right? Well, if we already have the 85, the 90, and the 150, we can just subtract that all from 360, and that should tell us how big of an arc is in there. 360 minus 150 minus 90 minus 85 leaves us with a 35-degree arc in here. 35 degrees. Don't write that down as your final answer, because remember we still have to do arc minus arc divided by 2. 90 minus 35 divided by 2, that's how we get the x is 27.5 degree angle. Next angle, we've got a vertex inside the circle, and so that angle is equal to the arc plus the arc divided by 2. Since this is the angle that we're looking for, and this angle would be the same as x, it's these two arcs that we would use. Those are sort of the intercepted arcs for those two. Hopefully that makes sense. So we are going to take arc plus arc divided by 2, and that comes out to 102.5. And finally, number 17, another one where the vertex of the angle is outside the circle. So we're going to need to take arc minus arc divided by 2. This arc, we would just have to take 360, the whole circle, and subtract off the 120 and the 90 that we already know about. That leaves us with 150 out there. Always take the bigger one minus the smaller one. That way you won't get a negative angle. And we wind up with x equals 30. Now switching over to these length ideas, this is the type where we do outside times whole equals outside times whole. So this one would be set up as the 14 from the outside. This whole thing would be 14 plus 10. And the other one is outside. And the whole thing is 12 plus x. And then we just have to solve that. So 14 times 24. Most of you like to distribute the 12. Subtract 144. And divide by 12 should be 16. The next one, it just has two intersecting chords, right? So the setup for that is we just take the chunk from one times the chunk from the same one. So we would take the 16 times the x and have that equal the 7 times the 45. Any other combo is not going to work on this one. So 16x equals 315. Divide by 16. That perfectly. I wouldn't need to round that or anything. All right, last one. We've got a secant and a tangent segment here. I like to still use outside times whole. So for the secant, my outside is the 20. And my whole thing is the 20 plus the x. Or you could say x plus 20. On the other one, I like to still think outside times whole, but it turns out that the outside is 28. And the whole thing is outside, so the whole thing is 28. Or maybe you want to write that as 28 squared. Doesn't matter. You guys like to distribute, so we'll have 400 plus 20x. 28 squared, 784. Subtract the 400. Divide by 20. That one comes out evenly at 19.2. Make sure you look over lesson 1 as well. That's also on your quiz.